I'm going to show how to perform multimodal image analysis using BESA Research and Mind. To do that, you need data that is co-registered, which is true in my case, and I have it already opened in BESA Research. Next step is to mark a block and send it to the source analysis module. Once I have done that, I need to perform very classical analysis of spike. First, I need to mark the interval that explains high percentage of principal component, and I can just trigger Clara computation. Clara computation is finished, I can perform dipole fitting. To do that, I just need to drop the dipole and press Start Fit. The dipole will be fitted in the already set interval. I have it already done, and then I can send the results directly to Mind and create a project based on the information from BESA Research. To do that, I can use a batch function by pressing Fit menu and running batch menu. Here you can find batch named Mind, and you just need to press Open. Of course, you can assign this to the function key by pressing Windows key and, for example, F8 key on your keyboard. As an intermediate step, you just need to provide the name for your distributed solution. I will name it Clara. And then after a second, Mind will be brought to you. Everything is get from the data. You just need to press OK. You eventually need to provide ID. I will provide it as Mind. You need to add the data you want. Mind automatically filter out only ACPC coordinate system. You need to add Clara result as a functional image. And it will automatically load the dipole as well. So let's first start adjusting the Clara image. We can change the color map. I recommend using hot metal. We can adjust the window and level. See, we have a nice correspondence between the dipole and Clara results, but we also have some additional results in a Clara visible, however with lower amplitude. It would be nice to perform add the other modalities to this dataset to have more information about it. You can easily do it in Mind by pressing Data button and load DICOM directory. Here we can add the folder. We can also add another type of data in Nifty format. And here I have a Z value from the VBM analysis, which is not proper for co-registration, but I also have the raw data. I will use this for alignment between the volumes. Loaded. Before we move forward, I need to show you one tiny problem that we have with this dataset. When we look at the VBM data from the MRI and our T1 segmented data, we can see that the volumes are not aligned. To solve this puzzle, we need to align the volumes. Here is the button to do that. These scaled values from VBM cannot be directly co-registered. However, we can do it using this VBM T1. To do that, I need to press the Change button and make that the parent for this dataset is this T1. I will do it for both FLAIR and BBM. And this is our master data. You just need to click and press OK. Once this operation is completed, all the dataset will be aligned to each other. We don't need to co-register Clara because Clara was already performed on the T1. That is our master image. So when I press OK, I am done. And now you can see that this BBM is very nicely co-registered with our T1. We can move to the exploration state. To do that, we just need to verify that all alignment has been performed just by pressing this Verify button. And once done, we just need to press the Exploration button. You are asked if you would like to save the project. Of course, we would like to save it, and we would like to continue with the same project in the exploration stage. Once we are in exploration mode, we can have a deeper look on the data. Let's first look on our FLAIR image and our BBM image from the closer perspective. As we have seen previously, we see this frontal cortical dysplasia, which is difficult to say which one is the proper one. This is the assumption we have, but there is also a bit more regions here and there as well. Let's add to this our Clara results and our dipole. Of course, Clara is not visible because it's on the lower part of the stack. We can move it up and then it's more visible. We can, of course, apply also the opacity so it can be more visible. And then we can note that all of our activities are rightly pointing out directly on this place. Clara, BBM, and the dipole. We can double check with our FLAIR image very easily. You can see that it's also the tip of this anatomic change that we observe here. What to do next is to just place region out here in this hotspot. To data, add custom regions. You make a plus sign, you can zoom in, we can adjust the position as well as the radius. Apply. We would like to do the visualization of the results. You can just apply these two images and move to the visualization. And now we can even export this result to DICOM. Verification, we can just open this exported DICOM file using an example ITK snap. As you can see, our exported region is visible here as a white circle.